So in this video, we're going to be looking at the cosine law. So the cosine law is based on the same oblique triangle, so you can do it for a not right angle triangle. And you label all the sides with little C, A, and B, and then the angles are across from that side. So if you call this side little c, then the angle capital C is the angle across from that side. This side is B, that's angle B. If this side is A, that's angle A there. And then once you've done that, then this is the cosine law here, that c squared equals a squared plus b squared minus 2ab cos of angle C. And notice this is true for any triangle, so it doesn't have to have a right angle in it, unlike Pythagoras' theorem or SOHCAHTOA, which are only true for right angle triangles. But let's see what it simplifies to when you have a right angle triangle. Like, what if your triangle looks like this, where this is side C, this is angle C, this is angle A, so that'd be side A, that's angle B here, that's side B there. So this is a right angle triangle. Well, what would be Pythagoras', or what would be the cosine law then? So we'd have C squared is A squared plus B squared minus 2AB cos of angle C, but take a look at angle C. Angle C is a right angle here, so that's 90. Well, what is cos of 90? Cos of 90 is actually 0, so that makes this whole thing is 0 there. So that's going to make that entire term 0, right? Because 2ab times 0, anything times 0 is 0. So this whole thing will simplify to c squared equals a squared plus b squared. This would just be minus 0, or nothing there at all, which is the Pythagorean theorem. So that should make a lot of sense. If we have a right angle triangle here, so that's a right angle, then the cosine law just turns into the Pythagorean theorem for us. All right, let's try an application problem with the cosine law. So let's say you have a Bombardier C-series plane that's 15 kilometers from an air traffic control tower. So I'll just draw the picture here. So here's the tower. This is the tower there. And then this is sort of the north direction here. So that's just north in general, right? And then east will be this way from there, northeast, southwest. The Bombardier plane is 15 kilometers from the tower. It's at an angle of 30 degrees east of north. So what I want to do is draw, this is going to be 30 degrees in here. And then this whole length here is 15 kilometers long. And right there, I'll call it B, that's the Bombardier plane. Then there's also an Airbus, and the Airbus is over here. Let's call that A for the Airbus. And it is 16 kilometers from the tower. And the angle from the north, so the angle is 40 degrees east of north. So this angle in here is 40 degrees. All right, so that actually lets me figure out what this angle is here, the angle in between A and B, the angle in between the line to the Bombardier and the line to the Airbus. Well, if it's 30 degrees there and 40 degrees here, then that angle would have to be 10 degrees, right? Or that's 40 minus 30 in there. So what I have is a triangle where I could call this side maybe C. This angle in here is 10 degrees. I have this side is 16, maybe I call that side B. This side I could call A, is 15 kilometers. What I'm trying to find out is how far apart the two planes are. So I'm really looking for the length of side C. And what we are worried about is it needs to be bigger than 2 kilometers. If the planes are within 2 kilometers of each other, then the control officer needs to radio them and to avoid a potential crash. So let's use our cosine law. So c squared is a squared plus b squared minus 2ab cos of angle C. This is already really nicely rearranged for c squared here. Let's just plug our numbers right in. So A is going to be the 15 kilometers. B is this side here, which is 16 kilometers. So 2 times A is 15, B is 16, And cos of C, C is the angle in between A and B, opposite side C, right? So that's the 10-degree angle in there. You can just plug that all into your calculator. So 15 squared plus 16 squared minus 2 times 15 times 16 times cos of 10. And that gives me C squared equals 8.29. And then I need to square root both sides to get C on its own. And that gives me C equals 2.88 kilometers. So that means we're good. The planes are more than 2 kilometers apart, so we're not worried about them crashing. So that's a good thing. All right, let's say you have a triangle that has 3 sides. There's side A here is 12. Side B is 15. Side C is 9. So this would be angle A right across from side A. This is angle B. That's angle C. And we want to find all of those angles. All right, so we can start by writing down the cosine law. C squared is A squared plus B squared minus 2AB cos C. This is going to be handy because I know side C, side A, and side B. The only thing I don't know here is cos of C. I don't know that angle C, and that's what I'm going to solve for. So let's start by moving the A squared and the B squared first to the other side. So we'll get C squared minus A squared minus B squared will equal negative 2AB cos of C. And then we can divide both sides by the negative 2AB. That'll get rid of our negative 2AB here. And we get a nice equation for cos of angle C, which is C squared minus A squared minus B squared, all divided by negative 2AB. So let's plug in our numbers here. So C squared is 9, so 9 squared, minus A squared is 12, minus B squared is 15, all divided by negative 2. A is 12, B is 15. And then just plug that whole side into your calculator. So 9 squared minus 12 squared minus 15 squared. Divide that by negative 2 times 12 and the 15. And what we get is cos of C equals 0.8. How do I get C on its own? Well, I need to inverse cos that. So C is going to be the inverse cos of 0.8. And when I do that, I get that angle C is 36.9 degrees. So angle C in here is going to be 36.9 degrees. All right, now how are we going to get all of the other angles? Well, we have to actually just repeat this process for another angle in here. So what I'll do, I'll get rid of all this. You can also use the sine law too, by the way, but we'll use the cosine law just because we're kind of on a roll with the cosine law here. So let's try and find angle A next. If I want to know angle A, I need to use a different form of the cosine law. So the basic form of the cosine law is this. C squared equals A squared plus B squared minus 2AB cos of angle C. If I want to make this angle in here angle A, then that means instead of being a C over here, this would have to be side A. So what I would do is I'd say, well, A squared is equal to, instead of A here, this is going to become C. This will still be B. Minus 2, and then instead of AB, this is CB, and then this gets to be cos of angle A. So this is another form of your cosine law, which lets you solve for angle A. Still the cosine law, it's just a different form of it. We can rearrange it the same way as last time, so I'll do A squared minus C squared minus B squared, all divided by negative 2CB will equal cos of A. Plugging in your numbers, that'll be cos of A is side A, so 12 squared, minus C squared, that's 9 squared, minus B squared, the 15 squared, divided by negative 2, C and B. And when I plug that into my calculator, I get 12 squared minus 9 squared minus 15 squared, divided by -2 times 9 times 15, I get 0.6. So cos of A equals 0.6. That means that A will be the inverse cos of 0.6, which is 53.1 degrees. So this angle in here, angle A here, is going to be 53.1 degrees. All right, now we could repeat this process one more time with the cosine law rearranged for angle B, just to show you what that cosine law is. So you kind of have all three forms of the cosine law. I'll write it down, but there's a much easier way to do it, so we're actually going to do it an easier way. I just want to have all the different forms written out for you so you know what they are. All right, so the form of the cosine law you could use to get angle B would look like this. B squared would be A squared plus C squared minus 2AC cos of angle B. And we could rearrange that one for angle B. That would work. But a way easier way to do this is just to use the fact that all angles in a triangle add up to 180. So that means that 36.9 plus 53.1 plus angle B has to add up to 180. So solving that for angle B, we would get that angle B is 180 minus 36.9 minus 53.1. And that gives me actually 90 degrees. So angle B ends up being 90 degrees here. So this actually ended up being a right angle triangle. We didn't know that at the start, but it is here. All right, so two cases where you use the cosine law. So one is, this is like the Bombardier Airbus problem here. If you have two sides, so say side A and B, and you know the angle in between them, that's one case where you want to use the cosine law. Remember the sine law we used if we have two sides and we know an opposite angle, like if we knew this angle, angle A here, or angle B, that would be a sine law situation. But if we know angle C, the angle in between the two sides, that's a cosine law situation. The other time you'll use the cosine law is if you only know sides and you know no angles at all. So you just know sides A, B, and C, you don't know any angles, that's another case where you need to use the cosine law. So those are your two times to use the cosine law. We would really only use it if we don't know that it's a right angle triangle or it's not a right angle triangle. If it's a right angle triangle, SOHCAHTOA and Pythagoras' theorem will always be easier.